Right. Okay. In this video, I'm going to discuss about the advantages of connecting lamps in parallel. Right. Now, as an example, if this bulb is broken, right? So if this bulb is broken, if it is not going to work, the circuit does not connect uh, a complete loop, right? I mean, you can see if this is broken, the current will not pass through this bulb, right? In a case like that, the other bulbs are also not working, right? If one bulb is broken or if it is not working properly, if it is not passing current properly, even the other bulbs will not work. But if you consider a parallel circuit, now suppose this is not going to work well, so it is not going to pass current, but doesn't matter what the other bulbs work well. That is the main advantage of the parallel and uh, of the circuits when we connect lamps in parallel. So if one is broken, if it is not going to pass the current, right, the series in a series circuit, the other bulbs will not work, right? If one is not working, but in parallel, if one is not working, the other bulbs will work, right? There are other advantages as well. You can calculate the power and so on, right? So if I consider this is R, and let me consider instead of E, I'll get the numbers, then it is much easier. So here it is 12 volts. And so let's get right here it is, right, we have 4 ohms, right, for each bulb. 4 ohms, 4 ohms, 4 ohms, 4 ohms, 4 ohms, 4 ohms. Here also 12 volts. Now you can simplify the total resistance of this one. It is going to get uh, 12 ohms, because R1 plus R2 plus R3 is equal to uh, R total. R1 plus R2 plus R3. So here it is 4 plus 4 plus 4. It is going to be 12 ohms, the total resistance of this one. Right. Then if you consider same scenario here, 1 over RT is equal to 1 over R. 1, let me write the equation, 1 over R1 plus 1 over R2 plus 1 over R3. Right. So if I simplify this one, I'll get 1 over RT is equal to 1 over 4 plus 1 over 4 plus 1 over 4. Then I'll get 1 over R3, the common denominator, it is 4. So here it is 3. Then I'll get RT as 4 over 3 when I cross multiply this thing, right? I'll get the total resistance of the circuit is 4 over 3, and here it is 12 ohms total resistance. So you can see here the resistance is greater and here the total resistance is smaller, right? Okay. Then you can calculate the current which is moving through the circuit. If you have the total resistance, you can get the current which is moving across the 3 circuits. And you don't need to calculate the current in each branch. You can calculate the current in each branch. Why? Because here if it is 12, the potential difference across here also 12, because they are in parallel, right? They are in parallel. So here also 12. So when you apply V equals IR to a lamp, V equals IR to a lamp in here in a parallel circuit, then you get here it is 12 volts. We need to calculate I, and R is 4, right? Then we can get I as 3 amperes. So the current here, it is 3 amperes. Here the current is 3 amperes, and here the current is 3 amperes. And you can see the junction here. Now here 3, here 3, here 3. So the current which is moving from this junction should be 9 amperes, because when 3 goes from here, there should be 6 amperes here. When another 3 goes from here, then there should be 3 amperes here. Then it will come back and connect. Here it is going to be 6 amperes, and here it is going to be 3 amperes. And when they connect, here it is going to be 9 amperes, right? Okay. Then you can see in each branch current is 3 amperes. current is 3 ampere. And if you consider the circuit here, and if you apply V equals IR for this circuit, you can simplify this 3 resistors into one single resistor. It means you can get a circuit like this, right? One single resistor, which is 12 ohms, and here you have the battery, which is 12 volts. So here also 12 volts potential difference, since they are in parallel. So you can apply V equals IR and get the current. You can apply it to the lamp, right? Then you can get the current. So it is going to be 12, and here the current is what we need to find. R is 12. Then we get the current. It is 1 ampere, right? Current through this circuit is 1 ampere. If the current through this circuit is 1 ampere, the current here should be 1 ampere. Why? Because the current in a series circuit is same at any point. I told you this one. Current in a series circuit is same at any point. So here also 1 ampere, here also 1 ampere. So you get the current like this, right? And you can calculate the potential difference now. If you apply the V equals IR, so it is 4 times 1, which is 4 volts. And here you get 4 volts here, right? Here also 4 volts, here also 4 volts, right? Then you can calculate power in a bulb here. If you calculate the power in a bulb here, it is V equals VI. Then V is going to be 4 volts times the current is 1 ampere. Then you get 4 volts, the power consumed by a lamp in a series. But if you apply the same equation to here, to this circuit, then you can get power is equal to VI. Then you see here the voltage across the lamp is 12 and the current is 3 ampere. Then if you get this one right here, you get, as you can see here, it is 36 watts, right? You can see what much greater amount of power consumed by a lamp here, right? So these lamps will get much greater power, which means it will have a greater brightness, right? The main thing, as I told you, when one bulb is broken, the current will not pass in a series circuit. So the other bulbs will not work. But in a parallel circuit, when a bulb is broken, so even if it is not passing the current, doesn't matter, the other bulbs will work. And you can see the total resistance. Total resistance is what? Smaller in a parallel circuit, right? Total resistance is greater in a series circuit. Then I can simplify this circuit into a one single resistor, as you know. Then I can find the current. Then that current is equal to the current moving through this circuit, because current in a series circuit at every point, it is same. Current is same at every point in a series circuit. So here I know the current, right? I know the current. Then I can apply V equals IR. I can apply V equals IR for a lamp. Then I can find the V, potential difference. Then I'll get current is 1 ampere, R is 4. Then I'll get the potential difference as 4 volts. Then here I have written 4 volts here, 4 volts here, 4 volts here. Then I can calculate the power of a lamp in a series circuit. Power of a lamp in a series circuit. Voltage is 4 volts, current is 1 ampere, so I get 4 volts. And if I do the same thing in a parallel one, in a lamp in the parallel circuit, so here I have 3 amperes, here I have 3 amperes, right? And 12 volts, then I get 12 times 3, 36. Right? How do I get 3 amperes in a branch? Because I know the potential difference of the EMF of the cell is 12, battery is 12 volts, then we should have the same potential difference across these branches in a parallel circuit, because they are equal in a parallel circuit. So I can apply V equals IR for a lamp, then I can get the current. This is what I have done. I apply the V equals IR for a lamp because I know the V, I know the R, then I can find A. So for each branch, we get a current 3 amperes, right? So if we want 3 amperes current for each branch, right? 3A, 3A, 3A. So we should have 9 amperes of current here in the main branch. So here we have 9 ampere. When 3 ampere goes into this direction, we have another 6 amperes. Then when another 3 ampere goes into this direction, we have another 3 amperes. Then they will come back at the same way. So this is how you can uh, analyze a parallel circuit as well as a series circuit. Okay.